Здравейте, аз съм Алекс. Ще правя тази презентация на английски, защото е по-лесно за мен. So yes, why Elixir is best for AI agentic systems. So from the people who have heard of Elixir, how many of you actually have wrote any Elixir? Okay, one, two, okay, maybe. Nice. So before we begin, I gotta get my clicker, because I can forget. 1 second. That's playing cards. There you go. Oh, it doesn't work. Oh. Okay. Super. So yeah, let's define what Elixir is. Elixir was founded in 2012 by Jose Valim, and it's powered by Erlang. Which is a very important aspect to what Elixir is. Erlang is a functional programming language made in the 1980s. I will talk about it in a little bit. And what Elixir is basically just a nicer way to program in Erlang. It gives you better tooling. It's a lot more easier to read and write, and has a stronger community behind it as well. So with that, yeah, Elixir is Erlang plus a modern developer-friendly experience. So that begs the question then, what is Erlang and what is the Beam? For that we have to go back to the future to 1985 when Ericsson was developing their telecom systems. And they had a big problem in Ericsson. They were using this language called Plex, and Plex wasn't really doing the work it needed to do. As more and more people started joining the telephone network, they realized that this system will not scale. So they had to figure out how can they make a system that supports thousands of calls every single day, and they sat down, and these are the requirements. So massive concurrency, thousands of calls happening every single second simultaneously. We need zero downtime. So you can't reboot the phone system while the people are on the phone. You can't upgrade it while the people are on the phone. You have to upgrade it during live phone calls. It has to handle huge amounts of spikes. So back in the days when there was an advertisement, a phone number comes on the TV, people started calling, that was a huge spike in the network. It had to be fault-tolerant. So if one phone call failed, it shouldn't crash the whole system. And the same thing applies for recovering from that failure. So if something fails, you have to try to recover from it. And this is why in 1986 they invented Erlang. Joe Armstrong, Robert Verding, and Mike Williams, they sat down and created basically what powers about 90% of the internet traffic going through our routers and switches today. It is built for durability, it's built for reliability, it's built for scalability, it's built to solve all of the problems. It's built, and it actually comes from this, the 9 nines. You know, the 9 nines of availability, it's come from Erlang. So let me explain a little bit how Erlang works. Erlang, there's two main things really to it. First you have the Beam VM. So this is a virtual machine. Now it doesn't work like other virtual machines. It works on one process rather than the OS processes. And within that one process, it can spawn a bunch of sub-processes, which are incredibly lightweight. They're incredibly lightweight. You can spawn millions of them. There are about 2 kilobytes per process. And it's extremely easy and cheap to run these. So I'm not sure how many technical people are, but you got one scheduler for one CPU, and that will handle all the processes for it. It also has built-in distribution. So if you have one Beam VM here, you have another virtual machine VM here, they can communicate through TCP. So this is really what powers the concurrency of Elixir. Next is OTP. So OTP, it stands for Open Telecom Platform, but that's not really important. The important part is the philosophy behind how we structure resilient systems. So there's 2 concepts that you have to understand. There is gen servers and there are supervisors. Gen servers, if you've ever worked with workers before, they're essentially your worker. Supervisors, the main job of the supervisor is to just watch out for the gen server. So what happens is, over here, the supervisor is watching this process, also called a gen server. This process is running, it might crash. This is going to realize it, and this is going to try to restart it. It's going to try get it up and running again. But on top of this, on top of the Beam, on top of the OTP, and by the way, when I say Erlang, when I say Elixir, I actually just mean the Beam VM. They're all the same thing. One of the core philosophies of this language is let it crash. Now, when I first learned this, I was shocked. I was completely, like, what do you mean? How can you let your system crash? You actually encourage crashing in your system as a developer when you're building things in Elixir or Erlang. And I'll try to demonstrate as best I can why. Here are some JavaScript code, and I'm sure any JavaScript developer can tell me why this is wrong. But this will crash because perhaps you don't have the name of the user, perhaps the DB isn't defined, perhaps the ID of the params isn't there. And if this crashes on your production server, it's gonna stop all the other requests happening. That's just the fact of JavaScript, that's just the fact of Node and Express. There are, of course, ways around it, and one of those things, as the JavaScript community made, is the try and catch. You know, you try and catch pretty much everything in JavaScript. I've been in try and catch hell previously in my last job. But this is how you solve the problem. This is how the problem of making sure your system doesn't crash is handed over to the developer. You have some business logic here in the if statement saying, you know, if the user isn't found, return 404. But you, as a developer, have to think about making sure your application doesn't crash. So Elixir, Erlang, Beam, they flip it completely on its head. And what I mean by this is the same code written in Elixir. And the idea is that, sure, we still have an if statement. In this case, it's a switch case. Oops, sorry. And we might not have the name of the user. So this will crash, you know, this will crash, but that's absolutely fine, because if you go back to this to this graph here, it's going to crash here, and it's only going to crash for this user request. It's not going to bring down the whole entire system, because every single process here is isolated. It's not shared across the states. It's not shared. It's isolated in its own little bubble. So I just want to quickly say, Sasa Gyurov did a presentation a few years ago displaying this table here, and it really kind of shows you the power of Elixir and Erlang. You have server A, which you know, you have your technology requirements. You know, you need long-term processes, you need background jobs, you need databases, and you choose to go with a bunch of different technologies to solve that specific problem. And that builds a team where you have specialists. You know, you have Dave over there, who's really great at, oh, shit, sorry, went to the other slide. You have Dave over there, which like really is into Redis and knows how to Redis. You have someone who's really into MongoDB. And if you take a look at server B, it's all can be done by just one language, and that's Erlang, and that's the Beam VM. And the whole point of Elixir, the whole point of Elixir Erlang is simplicity. We as developers want to build simple programs to solve complex problems. We don't want complexity. We want simple design, simple testing, simple deployment, simple maintenance, because it just makes everything much more faster. And like the slide says, it makes everything more uniform. And yes. So as you saw already, what powers, what companies use Elixir and the Beam? Well, one of the biggest companies handling billions of messages every single day. That's WhatsApp, that's Discord. Every one of these companies, they go through the Beam VM because it's reliable, because it's stable, because it's resilient. Now, I know I'm doing a really quick crash course on Elixir, but let's go through the recap. So OTP is the framework to build scalable and fault-tolerant systems because of the supervisors, because of the gen servers. Processes run on the Beam for massive concurrency. And Elixir compiles directly to the Beam. Okay, so on to the AI part. How does this evolve? How does this translate into AI agentic systems? Well, let's first define what a system is, an AI agent. This is a good quote from IBM. It is a system which takes decisions on behalf of the user by designing its own workflows and using its available tools. So if we expand that a little bit more, you can kind of see here all of the different things that go into an AI agentic system. You have tooling, you have orchestration, you have scheduling. Self-healing is a very important one that many people mislook because we all know how non-deterministic LLMs can be. So these are some of the things that are in an agentic system. And I want to kind of take you back to this slide here, when Ericsson set out to build a very fault-tolerant system. You need to have massive concurrency. Well, yes, you need to have a bunch of people using your AI. You need to have zero downtime. Your AI should always be working on your website. You should be able to handle huge amounts of spikes, fault tolerance. So one AI agent fails doesn't mean it crashes your whole system. It only crashes that. And you need to recover from failures automatically. So in a way, self-healing, recovering automatically, zero downtime. It's a very similar comparison to what a good AI agentic system should be. Or in fact, any system, really. So I'm going to take you back to this model because it's really simple to understand. Like, a lot of people don't believe how simple it is. Once you realize the beauty of it, you kind of unlock a new world. It's great. So here you have the OTP framework. And of course, it's a little bit simplified, but it's pretty much this. You have gen servers, you have supervisors watch over the gen servers. In a real-world application, you're going to have your HTTP server, your HTTP supervisor, which takes care of all the HTTP requests coming in. You're going to have a pub/sub supervisor, which is WebSockets, real-time. If a WebSocket connection becomes dodgy, that supervisor is going to realize it. It's going to go and try to restart it. The same thing with the DB supervisor. You have a DB connection. Something happens with DB connection. Supervisor is there to restart it. And for background jobs, OBAN as well. So we're going to focus on AI agent supervisor. This is what I've been doing for the past 6 months full time. And take you through the process of what AI agent supervisor really is. So imagine you have a chat widget on your website. User clicks on that chat widget and starts typing to your AI system. That's going to spawn a agent supervisor. So if another user comes along, it's going to also spawn another agent supervisor as well, just for that user, just for that session. So user says, hey, can I do a web search? Can you check the oil prices of the day? So it's going to go ahead, it's going to start querying, going to start scraping the web. And then user's like, well, actually, hold on. I want to get a calendar invite to this event I'm going to have. So the AI supervisor spawns a new process, and it's going to do it independently, isolated in a different process for that calendar invite. Then what happens? Well, of course, the LLM fails. It doesn't parse the HTML. It doesn't parse the JSON. No problem. It's just going to go and restart it, and it's going to try again. And of course, this is configurable in the settings that you write. The calendar is done, disappears, the process gets deleted, and then this succeeds at the end and returns the state back to the user. It's really that simple. What does it look like in code? Well, this is it. This is your calendar invite process. Now, the top two functions are just like boilerplates. You have to have them to initialize the state and initialize the link with the gen server. And down here at the bottom, you have your handle cast, which is the actual async task that you want to happen in your code. For instance, sending a calendar invite. Then you have the actual supervisor, and there's the AI agent supervisor here. Again, first two are just boilerplates, initializes a few things, and then you have these functions to start the web search and start the calendar. And how does it look like when you're executing it? It looks like this, which might look foreign for some people, but once you get the hang of it, it's actually quite nice syntax. And I haven't even spoken about how Elixir has pattern matching and piping into different functions. In general, it is a fantastic language to use. So I want to say that AI in production, it's actually very hard to achieve. It's a lot of thinking behind it. These are just some of the other things that you have to bear in mind when you're building an agentic system. And don't take my word for it. Don't take my word for it why Elixir is amazing. Elixir is being ranked top as the most admired languages for the past 5 years in the Stack Overflow developer studies. Do you remember Stack Overflow? Yeah, right. Yeah, dead. And also, if you do, by any chance, like Erlang and like Elixir, they are the top paying jobs so far, at least from 2024. So just because you haven't heard of it, just because it's a small niche language, and technically it is a small niche language, that doesn't mean there are companies that are paying a lot of money for your expertise and specialties. So I really apologize for such a condensed talk in Elixir, Erlang, and AI systems, but that was it. That's me. If you want to have more readings, I have the book here, which is written also by Sasa Jurek. He did also another fantastic talk, The Soul of Erlang and Elixir. And Gyurov is a developer-friendly agentic framework, which you don't need to know Elixir to start using it. But yes, that's me. Thank you for listening. Do you have any questions?
How is the situation with the frameworks for building AI agents in Elixir? Everyone right now is building for Python, for TypeScript, whatever. How's the situation with the frameworks?
Well, it's native. This is native. This is a gen server. This is a supervisor. So this is already built in Elixir. There's no library you need for this.
Okay, but for TypeScript, let's say you have libraries which are like proxies to work with all kind of different LLMs, because every LLM have a different API or whatever. So you get this out of the box. Is there something like this in Elixir?
Of course, there's libraries which communicate with OpenRouter or LangChain, for instance. So the brain is another process. So if you imagine going and contacting OpenAI or Gemini or whatever, you'll just have another process here, which is go send a request and get the result back, and then continue along with the workflow. So yeah. Yep.
How is the token efficiency when you generate code for Elixir versus Python, for example, for the same?
Yes, there was a recent study done. It was a great question. A recent study done of comparing a bunch of different languages with a bunch of different LLMs, and Elixir scored 90% in the benchmark in terms of the ability to complete the code. That is because Elixir syntax is really nice to read. It's really sensical. I wish I had an example here, but you basically, if you have a variable x, you can pipe this x into this function, and the result of this function, you can pipe it down into this function. And it's literally, the syntax is the pipe symbol with a little arrow. And it goes tack, 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 tack. And it's one of the reasons why it ranked so high, because it was easy for the LLMs to understand Elixir code.
How is the debugger in Elixir?
Debugging is fantastic in Elixir because of the whole philosophy of crashing and making it sure that it crashes. And once it crashes, you can realize that, oh, it crashed here in this process. And you can have a massive stack trace. And because it's a functional programming language, everything flows down. Object-oriented languages, you can call over here and then call over there, and it's going to come back. Elixir, Erlang, it's one stream down. So if you have a problem in this stream, you can just go and see what called it, up, 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 up. And one of the other things I should say is, how does a telephone network not come down when they upgrade? They don't have a blue or green system. They literally have hot reloading, hot code swapping. So what that means is you go to the telephone system and you just replace that whole code, and it just magically upgrades the system. There's no downtime of upgrading a system.
We're hearing about advantages. What are disadvantages?
Very good question. Thank you. I'm glad someone asked. Yes, Elixir, the Beam.
Sorry,
Yeah.
can you repeat it?
Yeah, sorry. The question is, what are the disadvantages of Elixir, and specifically Beam? So there's one main disadvantage of Beam, and that is it's not very computationally fast. So if you're building a game engine or if you're doing some really math crunching numbers, it's not the language you should go for. This language is built for concurrency and stability, with the drawback of it's a very slightly slower than C, for instance. So if you're going to build a game engine, go with Rust or go with C. You know. Yes. Okay. Thank you. Thank you so much, guys. Super.
Много ти благодаря. Супер презентация. Последния път, когато съм виждал някой да е толкова пашенат за програмен език, беше някой, който пишеше на Rust.
Ето. Да.
Благодаря ви много. Това беше официалната част. Ще се радвам се видим следващата седмица на 21 във вторник в Барта, където говорим и ще ви били коктейли. И да, благодаря, че дойдохте. Сега ще сме тук още час и нещо. Да.
Въпрос, убеди ли се в това, което той твърди?
Ще прочета книгата. Да. Благодаря ви много. Сега сме тук още час и нещо. Ще може да си поговорим и да пием по още една бира. И да, надявам се това седмица пак да се видим.